Hello students, welcome to Anne's classes. We are doing rational numbers exercise 1E and this is from the new concise mathematics textbook by Selena Publishers. This is the revised edition NAP 2020 aligned. Exercise 1E is on page number 28 and the first type of questions that we're going to do is the multiple choice type. So what do we do here? We choose the correct answer from the options given to us. Question 1, in the following number line, points A and B represent. Okay, now this whole exercise is about number lines and we are going to learn how to draw a number line and how to read what is on the number line. So this is an integers number line. Now how do we know it's an integers number line? Can you see the arrowhead here and the arrowhead here at both ends? That means the number line goes on both sides endlessly. So we have 0 somewhere in the middle and on the right we have all the positive numbers and on the left we have all the negative numbers. Now as you can see, after 0 we don't have 1 here. 1 has been put here and 2 has been put there. Now why is that so? That's because the whole number 1 has been divided into several parts. Now how many parts? Now from here to here there's 1, 2, 3, 4 and 5 parts. Okay, so that means this will be, the first part will be 1 by 5. Second one will be 2 by 5. Then we'll have 3 by 5 and then we have 4 by 5. And here this is 5 by 5 and we know that 5 by 5 is equal to 1. That's how we got 1 here. Then if we continue, it's going to be 6 by 5, 7 by 5, 8 by 5, 9 by 5 and then this 2 is 10 by 5. Now 10 by 5, when you divide 10 by 5, you get 5 2s are 10. So that's how we have 2 here. Is that clear, children? And then when you continue, that is 10, isn't it? Then this will be 11 by 5, 12 by 5 and 13 by 5. Now here, as you can see, point B is here and what does that represent? It represents 13 by 5. Now similarly, on the left hand side, we have the minus signs, isn't it? The negative integers. And again here also it's divided into 5 parts. So this will be minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5 and similarly this is minus 5 by 5. When you divide 5 by 5 you get 1 which is minus 1 and then when you continue this becomes minus 6 by 5, minus 7 by 5, minus 8 by 5 and minus 9 by 5. So as you can see this is represented by A. So A represents minus 9 by 5. So the question is, what do points A and B represent? So points A and B, now A represents minus 9 by 5 and B represents 13 by 5. Now here as you can see we have mixed numbers, isn't it? Minus 9 by 5 is not given here in the last option, whereas everything else is mixed numbers. So let's write down now A is minus 9 by 5. Let's convert that to a mixed number. So that is minus 5 ones are 5, 6, 7, 8, 9. That's 4 by 5. So A represents minus 1, 4 by 5. Now what would B? B is 13 by 5. Let's convert that to a mixed number. 5 2s are 10, 11, 12, 13. That's 3 by 5. So now B represents 2, 3 by 5. So now we have our answer. Let's look at the options that have these two numbers. So minus 1, 4 by 5. Where do we have that? We have here minus 1, 4 by 5 and 2, 3 by 5. So we've got both these. So what is our answer? Our answer here is option C. So you have to do this very carefully so that you get the right answer. Question 2. Now here it says using the number line given above. So I've drawn that number line here for you. This is from the previous question. We take the number line. The length of the line segment AB. So we have A here and B here. What is the length of this line segment? Now there are 4 answers given here. We have to choose one correct answer. Now how do we find the length of a line segment on a number line? Now one way of doing it is by counting from here and going up to that. So let's do that way also. So here we have Now 1, 2, 3, 4, 5, go up to B. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now this is 22 and this is divided by 5. Now why 5? As you can see, there are 5 parts. 1, 2, 3, 4, 5. And then we reach 1. Just like the previous question, we're using the same number line. Now from here, 1, 2, 3, 4, 5, 5 parts. Similarly here also 1, 2, 3, 4, 5, 5 parts. So we've got 22 by 5. This we convert to a mixed number. 5 fours are 20. Then the 21, 22, there's 2 left, and 4 2 by 5. So this is our answer, and that is option C. Now that is one way of doing where you count like this and write your answer like this. Now the other way of doing it is find the starting point here. What is the starting point here? Now here this was, now remember this is divided into 5 parts, 1, 2, 3, 4, 5. So this is 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. Then remember it's all minus 6 by 5, 7 by 5, 8 by 5 and 9 by 5. So this is minus 9 by 5. Minus 9 by 5. So that is the starting point. So minus 9 by 5 is the starting point, which is the ending point. So the ending point is here. So how do we find the ending point? Again, we start from here. Now from here to here is 5. From here to here is 10, 11, 12, 13. Okay, so that is 13 by 5. That point is 13 by 5. So the starting point is minus 9 by 5. The ending point is 13 by 5 and we subtract. So when you subtract the starting point and the ending point, you get the length of the line segment. So here, as you can see, the denominators are the same. So we put the same numerators also and we subtract. Here again, signs are the same. So we put the same sign and we add. 9 plus 13 is 22. Now here we are talking about something called the absolute value. Now, what is the absolute value? Now, when I put it between lines like this, that means the number inside should be written in the absolute value. That is, if this was a positive number, my answer would have been a positive number. The absolute value would have been positive. Now, this is a negative number. Even for a negative number, the absolute value is positive. That means, what is the absolute value here? 22 by 5. And now that you have 22 by 5, when you convert it, you get 4 2 by 5, which is the correct answer. So this is one way of doing where you count. You can count from here and then 1, starting from here 1, 2, and then go right up to the ending point. And we got 22 by 5. And we got this answer. This is the other way of doing it where you take the starting point, that is minus 9 by 5. You take the ending point, which is 13 by 5, and you subtract. Subtract the starting point and the ending point, and you will get an answer. The answer that you get should be written the absolute value. That means it should always be positive, even if it's a negative number. And then you convert and get your answer. So in both cases, you have found your answer to be 4 2 by 5. Now we're going to be doing inserting of rational numbers between two given rational numbers. You know what rational numbers are? Any number that can be written in the fraction form is known as a rational number. Now if you have two rational numbers, you are asked to insert rational numbers between them, you must remember that there are an unlimited number of rational numbers between two rational numbers. Now if I simply have to take two rational numbers, 2 by 3 and 5 by 7, there are many rational numbers between these two rational numbers. If I have to take 2 and 3, now there are many rational numbers between 2 and 3. Now 2 and 3 are whole numbers, but I can write them in the form of a fraction, so they are called rational numbers also. And there are many rational numbers that I can insert between 2 and 3 or between any two rational numbers. So you must remember there are an unlimited number of rational numbers between two rational numbers. We can insert infinitely many rational numbers between any two rational numbers. Then this property of rational numbers is known as the dense property. So this is something you can keep in mind because we can insert so many rational numbers without any limit, that property is known as the dense property. Now let's take an example. To find the rational numbers between minus 3 by 5 and 4 by 5. Now let's take the number line, integers number line. That's why there are two arrowheads so that we can show negative numbers as well as positive numbers here. So here, if I take this as 0, here we start with 0 here. On the right I have positive numbers, isn't it? 1, 2, 3, 4 and so on. On the left I have negative numbers, minus 1, minus 2, minus 3, minus 4 and so on. Now if I have to put it in the form of a fraction, I have to divide it into the number of parts that are there in the denominator. Now this is drawn just for you to understand. Now here between minus 3 and 4, so minus 3 is here, 4 is here. So let's mark that. So we have minus 3 here and 4 here. So if I have to write all the rational numbers between minus 3 by 5 and 4 by 5, now what will I get? I'll get minus 2 by 5, minus 1 by 5, then I'll have 0 by 5, 1 by 5, 2 by 5 and 3 by 5. So let's write that. To find rational numbers between minus 3 by 5 and 4 by 5, we'll have minus 2 by 5, minus 1 by 5, 0 by 5, 1 by 5, 2 by 5, 2 by 5 that is, and 3 by 5. So these are rational numbers between minus 3 by 5 and 4 by 5. Now, this can also be written this way. Now, minus 2 by 5, I can multiply this by 10. I can multiply both by 10. So, what do I get? I get minus 20 by 50. This is also 2 by 5 if I cancel the zeros, isn't it? Similarly, I can write 4 by 5 as 4 into 10 and 5 into 10, which is 40 by 50. So now I have these two rational numbers, minus 20 by 50 and we have 40 by 50. That means if I can write all the rational numbers between minus 20 by 50 and 40 by 50. They will also be the rational numbers in between minus 2 by 5 and 4 by 5. So here rational numbers between minus 2 by 5 and 4 by 5. Minus 19 by 50, minus 18 by 50, minus 17 by 50 and so on. We can go on and we can stop just before 40 by 50. So that can be 37 by 50. Now they're all positive numbers, 38 by 50 and 39 by 50. So can you see we can insert a number of rational numbers between these two rational numbers. So like we said, there are an unlimited number of rational numbers between two rational numbers. Now to find rational numbers between two rational numbers, there are different ways of doing it and we have explored the different ways in all the other questions as we do it in this exercise, and you can choose the one that has been taught to you in your school. Question 3. The rational number between a by b and c by d is one of these options. Now this you must keep in mind. For any two rational numbers a by b and c by d, like these two, a plus c, that is you add up these two, and b plus d is also a rational number and its value lies between a by b and c by d. Thus we can insert a rational number between these two. So this is the rational number that can be inserted. So which option is that? That is option C. So our answer is option C here. Question 4. Two rational numbers between 1 by 3 and 1 by 2 are. Now, one of these options is the correct answer. Now, how do we find rational numbers between 1 by 3 and 1 by 2? Now, there are different methods, but let's use the method that we've always used even in class 7. So, what are the two rational numbers? 1 by 3 and then we have 1 by 2. So the first rational number is already 1 by 3. Now to get rational numbers in between, what do? We take this numerator and add it up. So 1 plus 1 and then take the denominator and this denominator 3 plus 2 and add it up. Okay. Now what do we have? So let's mark this. So now we have this first one here. We've added up these two. Now let's put this one back there. So that's 1 by 2. So let's write it 1 by 3. Here 1 plus 1 is 2. 2 by 5. Okay. That's one rational number. And then we have 1 by 2. So now we have 1. We have inserted one rational number. But the question is two rational numbers, isn't it? Now there can be many rational numbers. We can pick any two. So now what we're going to do is we're going to write this one, the first one, as it is. So that is 1 by 3. This is in the question, isn't it? Now we're going to add up these two. That is 1 plus 2 and 3 plus 5. So let's do that. So that is 1 plus 2 and 3 plus 5. And then we're going to write this, which we have already found. And then we're going to write the last one, which is 1 by 2. So now what are all the rational numbers? So 1 by 3 is the question. So 1 plus 2 is 3 and 3 plus 5 is 8. Then we have 2 by 5 and then we have 1 by 2. So now if you see, we have two rational numbers here between these two. But let's see if we have this in our options, 3 by 8 and 2 by 5. Now only 3 by 8 is found only here, but we don't have 2 by 5. Isn't it? That means we have some more rational numbers. Let's try and find some more rational numbers between 1 by 3 and 1 by 2. So 1 by 3 is the question. Then we found 3 by 8 is one of the rational numbers that we put in between. Now what we are going to do is we are going to add up 2 and 1, 5 and 2. So that will be 2 plus 1 and 5 plus 2. And then we already have 2 by 5. And then the last one is the question, which is 1 by 2. So now let's see. So here we have 1 by 3, which is the question. Then we have 3 by 8. Then let's add up. 2 plus 1 is 3. 5 plus 2 is 7. And then we have 2 by 5. And then we have 1 by 2. So now we have three rational numbers in between 1 by 3 and 1 by 2. We can pick any two here. So let's see which two are there in the options. So here we have 3 by 7 and 3 by 8. So here can you see we have 3 by 7 and 3 by 8 in between. So option A is the right one. Now if you look at the other options, B is 2 by 5 and 0. We have 2 by 5 but we don't have 0. Look at C, we have 1 by 6 and 2 by 3, which we don't have here. D is 2 by 3 and 3 by 2, which we don't have here. So which is the correct answer? Option A. Question 5. The rational number between minus 7 by 4 and 3 by 4 are represented by which of these letters? Now when the denominator says 4, that means between two numbers there are 4 parts. So we have 1, 2, 3, 4 parts. Okay, so you have to look at the denominator. Now we have to look for minus 7 by 4. So after 0 on the left side, the negative numbers will start. So this will be minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, minus 5 by 4, minus 6 by 4, minus 7 by 4 is here. So let's write that down. So here we have minus 7 by 4, which is asked in the question, minus 7 by 4. Now let's look for 3 by 4. It's positive, so it will be on the right side of 0. So 1 by 4, 2 by 4, 3 by 4 is here. Okay, so let's write that. So 3 by 4 is here. So we've got 3 by 4 from the question. So the question is, the rational number between minus 7 by 4 and 3 by 4 are represented by letters. So here it says B and E. No. What is the answer? C and D, isn't it? So B and E is the wrong option. C and D is also the wrong option. C and E. C and E is the correct answer. So this is the right option, option C. Question 2. Draw a number line and mark all these numbers on it, all these points on it. So first thing is to draw a number line. So let's draw a number line. So we have a number line here. It's an integers number line since there are negative numbers. So see the arrowheads. There should be arrowheads on both sides and then you have your numbers. Okay, so you have 0 first. So mark some place in the middle as 0. Now look at the denominators. It's all 4. That means you have to divide your numbers into 4 parts. So 1, 2, 3, 4, and then you'll get 1. Then again 1, 2, 3, 4, you'll get 2, and so on. So here we've got 1, then here we have 2 after all 4 parts. So can you see this 1, 2, 3, and 4 parts here, and then you have your number. Similarly, on the other side, 1, 2, 3, 4, you will have minus 1. Again, 1, 2, 3, and 4, you'll have minus 2. So now we have our numbers. We have written everything. We have to draw the number line and mark these points on them. So let's see where these points are. Now 3 by 4, it's a positive number. First thing, look for the positive sign. So this is a positive number. It will be on the right side of 0. So here we have 0. The first one will be 1 by 4 fraction, 2 by 4, and this is 3 by 4. So we can mark the point here. So this is going to be 3 by 4. Let's write it 3 by 4. You have to mark these points instead. So we finished marking 3 by 4. So now let's go on to next one, which is 7 by 4, which is also positive. So this is 3 by 4. This will be 4 by 4. Then 5 by 4, 6 by 4, 7 by 4. So that is 7 by 4. That is this point here. So let's mark that clearly. 7 by 4, and let's write it 7 by 4. Now the next number is minus 3 by 4. That means it's a negative number. It will be on the left side of 0. Minus 3 by 4. So this will be minus 1 by 4, minus 2 by 4, minus 3 by 4 is here. So let's mark that. So this part is minus 3 by 4. Let's write that. Minus 3 by 4. We finished that also. Let's go to the next one. Minus 7 by 4. So we have minus 3 by 4, minus 4 by 4, minus 5 by 4, 6 by 4, and 7 by 4. So minus 7 by 4 will come here. So this point will mark it, and this is minus 7 by 4. So now we have marked all that we've been asked to mark here. So we've been asked to mark 3 by 4, and we have 3 by 4 here. Then we have 7 by 4, we have marked 7 by 4, minus 3 by 4 is here, and minus 7 by 4 is here. Question 3. On a number line, mark these points now. Okay, so let's do that. So we have drawn a number line with 2 arrowheads. Now put your 0 now. Look at the denominators. It's 3. That means we are going to divide this into 3 parts. So 1, 2, 3, we will have 1. Then again 1, 2, 3 will have 2. So similarly 1, 2, 3 will have 3, and on the negative side minus 1. Here 1, 2, 3 minus 2. So now let's mark this. So first one is 2 by 3. So it's a positive number. It's going to be on the right side of 0. So this is 1 by 3. This is 2 by 3. So let's mark that. So this is 2 by 3. 2 by 3. The first one is over. Then we have minus 8 by 3, which is on the left side of 0. So 1 by 3, minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 4 by 3, minus 5 by 3, minus 6 by 3, minus 7 by 3, minus 8 by 3 will come here. So let's mark that. So this is minus 8 by 3. Next one is 7 by 3, which is a positive number. So let's do that. 7 by 3 is on the right side of 0. So we have 2 by 3 here, 3 by 3, 4 by 3, 5 by 3, 6 by 3, 7 by 3 is here. So let's mark that. 7 by 3, this one, and 7 by 3. So we finished that. Next one is minus 2 by 3. So it's a minus number. It will be on the left side of 0. So minus 2 by 3 is 1 by 3. Minus 2 by 3 will come here. So this is minus 2 by 3. Then the last one is minus 2. And we can see minus 2 very clearly here. Minus 2 is here. So this is our answer. So let's mark the point there. So now we have marked all these points here, as you can see. So 1, 2, 3, 4, and 5 we were asked to mark, and we have marked them. Question 4. Insert one rational number between 3 by 5 and 5 by 8. So let's do that. So the two rational numbers given to us are 3 by 5 and 5 by 8. Now we have to insert one here in between. So for that we are going to add up the two numerators, add up the two denominators. So this will be 3 plus 5 and here it will be 5 plus 8. So that way we have three rational numbers here. So this will be 3 by 5 and what we have inserted, 3 plus 5 is 8 and 5 plus 8 is 13. And the other one is 5 by 8. So we have inserted one rational number and this rational number is 8 by 13. So that is your answer. Question 4, the second one here, that is insert one rational number between these two. So here we have 1 by 2 and 2. So whenever you have to insert rational numbers, there are different ways of doing it. One way is this, where you say 1 by 2 plus 2, 2 by 1. You take both the rational numbers and divide it by 2. That's the average, divided by 2. So first let's work out this 1 by 2 plus 2 by 1. So that will be 1 by 2 plus 2 by 1. So here we have to take the LCM, which is 2, and let's look at the numerator here and the denominator. Now the first rational number denominator is 2, 2 ones are 2, so multiply this also by 1. So 1 ones are 1 plus go to the second one, denominator is 1, 1 twos are 2, so 2 twos are 4. So here we have 4. So this becomes 5 by 2. So here we have 5 by 2, the whole thing divided by 2. So let me put it this way, 5 by 2 divided by 2, that is divided by 2 by 1. This becomes 5 by 2 into 1 by 2. So this is 5 by 2 twos are 4. Now let's convert this. Now 5 divided by 4, 4 ones are 4 minus 5 minus 4 is 1. So we can leave it like this 1, 1 by 4, or we can convert it to a decimal number. We can continue with the division. How do we continue with the division here? We have to put a point in the quotient, bring that point down. Now we can add zeros. So now I'm going to bring this 0 down. So my number is now 10. 4 twos are 8. So I'll write 8 minus 10 minus 8 is 2. Now I can continue putting zeros here. So bring that 0 also down. Now it's 20. 4 fives are 20. So minus 0. So if you have to insert a rational number between half or 1 by 2 and 2, the answer is 1.25. So you can have your answer in the form of a mixed number like this, or if you require, you can put it in the form of a decimal number. Question 5. Insert two rational numbers between these two rational numbers. So let's begin by writing these two, that is 5 by 7 and 3 by 8. If we have to insert between them, we are going to add up the numerators, that is 5 plus 3, and add up the denominators 7 plus 8. So here what do we have? We have 5 by 7, which is the first one as it is. Second one will be 5 plus 3, which is 8, and 7 plus 8, which is 15. And then we have the third one, which is there in the question. So now we have inserted only one. Our question says insert 2. So for this, we can add up these two, or we can add up these two. So first, let me add up these two and see what we get. So here, the first one is 5 by 7. Now we are going to add up and we're going to put it in between these two rational numbers. So that will be 5 plus 8 by 7 plus 15. Then we also have 8 by 15 and we have 3 by 8, which is given in the question. So this will be 5 by 7, first one, as it is. 5 plus 8 is 13. 7 plus 15 is 22. Then we have 8 by 15 and we have 3 by 8. So 5 by 7 and 3 by 8 are part of the question, and we had to insert two rational numbers between these two numbers, and we have inserted. Now here I have taken these two numbers. Now let's work with these two and see what we get. So I'm doing the same thing here. So I'm getting these here. So this is 5 by 7. Then we have 8 by 15. One is already inserted. And then we have 3 by 8 as part of the question. So here what did we do? We took the first and the second. Here let's take the second and the third and see what we get. So here we'll get 5 by 7 as it is. Then 8 by 15 also as it is. Then we're going to add up 8 plus 3 and 15 by 15 plus 8. And the last one will remain as 3 by 8. So here what do we have? 5 by 7 and we have 8 by 15. 8 plus 3 is 11, 15 plus 8 is 23, and we have 3 by 8. So here we have one set of answers. 13 by 22 and 8 by 15 can be two rational numbers between these two rational numbers. Here we can also have 8 by 15 and 11 by 23 as rational numbers here in between these two. So there are two ways of getting it, and I've shown you both ways. Question 6. Insert three rational numbers between these two rational numbers. Now here, let's use a different method. If that is being taught in your school, you can use it. That is the LCM method. So as you can see here, 8 by 11 and 4 by 9, the denominators are different. So we have to find first the LCM of the denominators so that we can make the rational numbers like. So they become like terms with the same denominator. So let's find the LCM of 11 and 9. So let's begin with 11. It's a prime number. 11 ones are 11 and then 9. Now we can use 3, 1 and 3 threes are 9. Continue. 3, 1 and 3 ones are 3. So what is the LCM here? 11 into 3 into 3. So 3 threes are 9. 9 into 11 is 99. So the LCM is 99. This is going to become the common denominator. So let's take the first rational number, 8 by 11. If the denominator has to become 99, 11 we have to multiply it by 9. So 11 into 9 will make it 99. Similarly, multiply this also by 9. So what do we get? 8 nines are 72 and 11 nines are 99. Similarly, let's take the other rational number, 4 by 9. Here the denominator has to become 99, so multiply it by 11. Multiply this also by 11. So here what do we get? 4 into 11 is 44 and 9 into 11 is 99. So now between 44 by 99 and 72 by 99, there are many rational numbers. You can have 45 by 99, 46 by 99, 47 by 99, right up to 72. By 99, you can have any number of rational numbers. So from these rational numbers, you need to pick out three rational numbers and that will be your answer. There are an infinite number, so your answer will be different from someone else's answer. As long as you follow this, you can pick out any three rational numbers and put them between 8 by 11 and 4 by 9. Question 7. Insert 5 rational numbers between 3 by 5 and 2 by 3. So first take the rational numbers 3 by 5 and 5 by 2 by 3 and find their LCM. The LCM of these two rational numbers with the denominators 5 and 3 is 15. 5 threes are 15. Now take the first rational number 3 by 5 and change the denominator to 15. Because 15 is the LCM. How can we change that? By multiplying the denominator by 3. 5 threes are 15. So multiply the numerator also by 3. So here we get 3 threes are 9, 5 threes are 15. Now take the second rational number, that is 2 by 3, and here also look at the denominator. We have to change it to the LCM, which is 15. So we multiply 3 into 5. 3 5s are 15. So multiply 2 also into 5. So here what do we get? 2 5s are 10, 3 5s are 15. Now why did we do that? Because here the denominators are different. Now we have changed them to rational numbers with same denominator. So that is the first thing you need to do. When the denominators are different, find the LCM and change the rational numbers in such a way the denominators become the same. Now we have 9 by 15 and 10 by 15. Since we have to find 5 rational numbers, we are going to multiply 9 by 15 and 10 by 15 by 6. If you have to find 5 rational numbers, you multiply by 6. If you have to find 6 rational numbers, you multiply by 7. So that's how we're going to do. I'm going to take 9 by 15 and I'm going to multiply this by 6. So let's multiply numerator and the denominator both by 6. So here what do we get? 9 sixes are 54 and 15 sixes are 90. Now let's take the next one, that is 2 by 3 or 10 by 15. We have converted this to 10 by 15, isn't it? So take that 10 by 15 and multiply this by 6 because we need 5 rational numbers. Multiply both by 6. Now 10 sixes are 60 and 15 into 6 is 90. So now what do we have? We have 54 by 90 and 60 by 90. All the rational numbers that come between these two will be the rational numbers that come between these two. So it can be, after this it is 55 by 90, 56 by 90, 57 by 90 and so on. So let's write that. So here we have the rational numbers given to us is 3 by 5 is the first one. Now we're going to write after 54 by 90, we have 55 by 90, 60 by 90, 56 by 90, 56 by 90. So we carry on like that, okay? 55, 56, 57, 58 and 59. So we have written the rational numbers between 54 by 90 and 60 by 90, and we have 5. 1, 2, 3, 4, 5. And then we write the last one, which is the question given to us. So these are the 5 rational numbers between 3 by 5 and 2 by 3. Now some of these we can reduce to the lowest term, so let's do that. So 3 by 5 we write as it is. 55 by 90 both are divisible by 5. 5 11s are 55. And 5 into 1 is 5 and then there's 4 left, 48. So 11 by 18. So let's write here 11 by 18. Next one, here let's cancel 56 by 90 by 2. 2 2s are 4 and then 1 left at 16. 2 8s are 16. This is 45. So the second one we have here is 28 by 45. Let's go to the next one. It's divisible by 3. 3 ones are 3, 4, 5, there's 2 left, 27. 3 nines are 27. Here 3 threes are 9, 30. So what is the next one that we have? 19 by 30. Next, we go to 58 by 90. Here 2 twos are 4, 2 nines are 18 and 45. So that is 29 by 45. Let's go to the last one. 59 by 90, that cannot be reduced to the lowest term. So we write it as it is, 59 by 90. And the question, which is 2 by 3. So as you can see, we have 5 rational numbers here between 3 by 5 and 2 by 3. Question 8. Insert 6 rational numbers between 5 by 6 and 8 by 9. So again, let's take the two rational numbers 5 by 6 and 8 by 9. And let's find the LCM of 6 and 9. 2 threes are 6. Bring down 9 as it is. Continue with 3. 3 ones are 3. 3 threes are 9. 1 and 1. So what is our LCM? LCM is 2 into 3 into 3. 2 threes are 6. 6 threes are 18. So 18 is the LCM. So take the first rational number 5 by 6. Now the denominator has to become 18. So 6 threes are 18. We multiply 5 also by 3. So here we have 5 threes are 15 and 6 threes are 18. Now take the next rational number 8 by 9. The denominator has to become 18. So we multiply 9 by 2. So multiply this also by 2. So 8 twos are 16. 9 twos are 18. So now we have 15 by 18 and 16 by 18. Both have similar denominators, same denominators. Here the denominators are different. That's why we found the LCM. Now we have to find the rational numbers between 15 by 18 and 16 by 18, and we need to get 6. So take the first rational number 15 by 18 and multiply both by 7. Why 7? If we have to find 6 rational numbers, we have to multiply by 1 more, that is 6 plus 1, 7. So now let's multiply both and see what we get. 15 into 7 is 105. and 18 into 7 is 126. Now take the next one, that is 16 by 18, and multiply both by 7. So this by 7 and this by 7. 16 into 7 is 112 and 18 into 7 is 126. So now we have 105 by 126, 112 by 126. The numbers between 105 and 112 will be the rational numbers in between. So here, let's write the first one. The first one is 5 by 6. And then we start writing the other rational numbers that we found. We have to find 6 rational numbers. So here we have 105. We're going to start with the next one, 106. So that is 106 by 126. Then 107 by 126. 108 by 126. 109 by 126. 110 by 126. Now we have 5, we have one more, 111 by 126. And we have the last one, which is a question given to us, 8 by 9. So these are the 6 rational numbers that can be inserted between 5 by 6 and 8 by 9. Now these, if you can, you reduce them to the lowest term. So let's write the first one as it is, 5 by 6. Now here 106 by 126 both are divisible by 2. 2 5s are 10 and 2 3s are 6. Similarly, 2 6s are 12, 2 3s are 6. So what do we have here? 53 by 63. Second one, 107 by 126 cannot be reduced, so we write it as it is. Next one, let's divide both by 2 first. 2 5s are 10. 2 4s are 8, 2 6s are 12, 2 3s are 6. Now 54 and 63 are both divisible by 9, isn't it? 9 6s are 54, 9 7s are 63. So here we have 6 by 7. Next we have 109 by 126, which cannot be reduced. So we'll write it as it is, 109 by 126. Next one, we can reduce it again with 2. 2 5s are 10. There's one left here. 2 5s are 10. 2 6s are 12. 2 3s are 6. So what do we have there? We have 55 by 63. And then the last one, both can be reduced by 3. 3 3s are 9, 10, 11. So we have 21 there. 3 7s are 21. 3 4s are 12. 3 2s are 6. So what do we have there? We have 37 by 42. And the final question, 8 by 9. So now we have 6 rational numbers inserted between 5 by 6 and 8 by 9. Question 9. So here, as you can see, both are whole numbers. So what we do is first we write them in the form of fractions. So 2 by 1 and 3 by 1. Now LCM will be 1 itself, isn't it? Now the denominators are the same, so you don't have to find the LCM. Since we have to find 7 rational numbers, we have to multiply the numerator and denominator by 8. 2 by 1, we have to multiply it by 8. So multiply this by 8 and the numerator by 8. 2 8s are 16 and 1 8s are 8. Take the second rational number, 3 by 1. This also multiply the numerator and the denominator by 8. So now what do we have? 3 8s are 24, 1 8s are 8. So now can you see both the rational numbers have the same denominator. Now all rational numbers after 16 by 8 up to 24 by 8 will come in between 2 and 3. That means 17 by 8, 18 by 8, 19 by 8 and so on. So let's write down the first rational number, 2. Then we can write what comes after 16 by 8, that is 17 by 8. So let's write that. That is 17 by 8, 18 by 8, 19 by 8, 20 by 8, go on up to 24, 21 by 8, 22 by 8 and 23 by 8. Okay, because we stopped just before 24 by 8. Now let's write the question also that's given, that is 3. So here we have all rational numbers between 2 and 3. 7 rational numbers between 2 and 3. So now these can be written as your answer, or you can reduce them to the lowest term. So let's begin with 2. 2 as it is. Then we have 17 by 8. You can convert it to a mixed number. 8 twos are 16 plus 1 17. 2 1 by 8. Now look at this one. So here we have 18 by 8, isn't it? Let's write it here. 18 by 8. First reduce it to the lowest term. Both are divisible by 9. Both are divisible by 2. 2 nines are 18, 2 fours are 8. So this is 9 by 4, and that can be converted to a mixed number. 4 twos are 8, 1 by 4. So that is 2 1 by 4. Let's write that 2 1 by 4. Next one. We have 19 by 8, which cannot be reduced to the lowest term, but you can convert it to a mixed number. That is, 19 by 8 will be 8 twos are 16, 17, 18, 19. That's 3 by 8. So that's 2, 3 by 8. Then we have 20 by 8. 20 by 8, let's take it to the working column here. 20 by 8. Both are can be reduced by 4. 4 fives are 20, 4 twos are 8. So this is 5 by 2, which can be converted to a mixed number. 2 twos are 4, 1 by 2. So that is 2 1 by 2. So after this we have 2 1 by 2. Then we have 21 by 8. Okay, so we finished with these. You need to be careful to see what you finished. Now 21 by 8 cannot be reduced, but we can convert it. 8 twos are 16, 17, 18, 19, 20, 21. That's 5. 2 5 by 8. Then let's go to 22 by 8. Let's see that. So here if I write down 22 by 8, I can reduce it to the lowest term by 2. 2 11s are 22, 2 4s are 8. So we have 11 by 4. Converted to a mixed number. 4 2s are 8. 9, 10, 11, 3 and then 4. So here we have 2, 3 by 4. Then we have 23 by 8. So let's convert that. 8 twos are 16. Then 16, 23 minus 16 is 7 by 8. And then we have our question 3. So what are all the rational numbers between 2 and 3? All these are rational numbers that come between 2 and 3. So hope you have understood, children. With this we come to the end of this exercise. Thank you, children.